I were attempting this problem, the first thing that I would do is I would analyze the atoms that are directly attached to the stereocenter to see if you can assign priority based off of atomic number. So you're analyzing this stereocenter right here that I just drew a star at, and we can see that this stereocenter is bonded to a hydrogen directly. It's bonded to a carbon atom directly. It's bonded directly to another carbon atom, and then it's bonded to another carbon atom. So then I would go on to analyze these. I think carbon has an atomic number of like 6. Hydrogen is 1. I'm sure you know that. So then hydrogen would have the lowest priority, which I saw did correctly. So can you tell these carbons apart right off the bat? No. So you're going to need to then analyze what those carbons are bonded to. So I would say like step 2 is then analyze the atoms that the carbons are themselves bonded to. So if I were analyzing this carbon right here, I could see that it's bonded to a carbon of that CH3. So I'm just going to write a carbon down. It has a hydrogen that's implied. I'm just going to draw that down there. And it's also bonded to another carbon down to the left. So I'm going to draw that carbon in right there. Now if I analyze this carbon of the isopropyl, you can see that it's bonded to a carbon of the CH3 and another carbon of the CH3. So I'm going to put 2 carbons for those. And it also has an implied hydrogen. So I'm going to draw that too. Now I'm going to look at the carbon to the left of the double bond. And you can see that it's bonded to an oxygen. There's no implied hydrogens because that carbon has 4 bonds already. And it's also bonded to a carbon down here. So I'm just going to draw that carbon in. So next, I would compare these 3 groups, I guess. So you can see here, there's 2 carbons and a hydrogen. Carbon has an atomic number of 6. Same with this group up here. There's 2 carbons, has an atomic number of 6. But when you come over here, you can see that this carbon is attached to an oxygen, which has an atomic number of 8. So since that carbon has an atom that has such a high atomic number, it's going to get that first priority. So I'm going to put a 1 in green on that carbon. I'm going to draw a new structure to make it hopefully a little less messy. Okay. So yeah, and you can see that these 2 groups right here that I'm circling in purple, you can't tell apart yet. So you're going to need to walk down to like the next atom that carbon is bonded to. So we have a 1 and a 4. So if we were just analyzing this carbon right here, we're going to walk down to either these 2 carbons that I just drew arrows to. They're both the same, so it doesn't matter which one you look at. So I'm going to take this carbon right here, and I'm going to analyze what it is attached to. Oh yeah, I also forgot step 3. If you cannot tell 2 or more groups apart, walk down to the next atom and analyze what that atom is attached to, which is what we're doing like right here. We're analyzing this carbon atom and what it is attached to. So you can see that it's attached to these 3 H's. So I'm just going to list that out. Got 3 H's. Okay, now we're going to move on to the other carbon that we were just analyzing. We were just analyzing this guy right here. So we're going to walk over to either this CH3 or this next carbon in the ring. This CH3 is the same as that CH3. It's just a carbon with 3 hydrogens. You can't tell those apart. Neither one of them will get priority over the other. So your best bet is to look at this carbon right here. I'm drawing a purple arrow at, so I'm going to erase this. So if you look at that carbon that I drew the purple arrow at, we have 2 implied hydrogens. We have that carbon atom, there's 2 hydrogens, and then it's bonded to another carbon upwards to the left. So I'm going to draw that out. And now when I compare what these carbons are bonded to, all these H's have an atomic number of 1. And then over here we have 2 H's that have an atomic number of 1, but we also have a carbon that has an atomic number of 6. So this carbon with the green star right here is going to have the second highest priority because of this. So now we're going to have a 2, and we have a 4. I'm going to redraw this and then do the arrows. So we have 1, highest priority, 2, 4, and then 3. So we can bypass that 4. That is in the counterclockwise position. So that would be S.